Mitochondria is the powerhouse of the cell. Welcome back to Anatomy 101. I'm doing sliding filament theory. I need help. Alright, so this is a thin filament, which is actin. This is a thick filament, which is myosin. Sliding filament theory is when the thin filament and the thick filament overlap one another during contraction. That shortens your muscle. That's when you can like flex on them haters. Now, when your muscle relaxes though, the thin and thick filaments then separate apart and only overlap slightly, so you get a little boop of the noses. Yee. Welcome back. I'm gonna do more sliding filament theories. So, my arm is now an axon terminal. Our lovely plant here, Harvey the Ivy, is our ACH receptors, and the straws are now the motor end plate. Now, when a nerve impulses reaches the end of the axon, represented here by our lovely little super pig, this is energy now. So the voltage-gated calcium channels open up, allowing calcium to go into the neuron. This is calcium. We're doing great. So calcium is now being able to release into the neuron. The sympathetic vesicles fuse with the axonal membrane, my arm, and release ACH into the sympathetic cleft. So this is our ACH in a sense. Wait, no. This is our ACH receptors. Super pig is now ACH. And they're released into the sympathetic cleft, which is like the space. There's like space in between. There's supposed to be like a gap in between those two. So the binding of the ACH to the receptors, so super pig to Harvey the Ivy. I will not actually squish Harvey the Ivy because I love the little plant. And the motor end plate opens. So these bad boys just kind of open right up. And so calcium and now sodium are able to just slither on in. Yeah, okay? And so once they're inside, this causes the interior or the sarcolemma to become less negative or depolarization, and the action potential is initiated. Once the action potential is initiated, it progrades. Welcome back. Now, Super Pig is action potential, or he was. Now he's not. Goodbye. I love you. Action potential will now be represented by these little black balls of Play-Doh. Now, once the action potential is released, it'll go down on this side of the sarcolemma and kind of just go on down, you know, just woo! And it goes down into the T-tubules, which is represented by our Q-tips. They're gonna go down, and once they're kind of in the T-tubules, then that's gonna really cause the reaction of calcium to be released from the terminals. So, yeah. Welcome back to sliding filament theory again. I'm sitting in a planter still talking about this because we need to. Anyways, so in the previous video we had the calcium ions go down the T-tubules, so now they kind of just trickle down, and the calcium ions then bind to the troponin, which is these black things that we have. Once they attach themselves just like that, totally like that, it allows the troponin to like change the shape, and so the blocking actin of the tropomyosin, which is this giant thing, it allows it to like change shape, which allows contraction to happen. Like this can also, it allows the calcium ions to now like get to this part, which isn't usually able to happen unless like the troponin is like allowing it to attach. So once that happens, the contraction, myosin cross bridges alternately attach the actin and detach. So this thing, they can detach and attach, pulling the actin filaments toward the center of the sarcomere, which is releasing the energy by ATP, hydrolysis powers, to the cycling process. So like, it just allows your muscles to relax, contract, and go back and forth. That's the whole point of the calcium ion, to like be able to attach to it. Yeah, go back to that. Now, once the removal of the calcium, say goodbye to these little boys, the removal of calcium by active transport into the SR after the action potential ends. So all that energy is now gone, so these babies they don't have enough energy to keep going. Not enough. So then, once they're gone, say goodbye to these little boys. The tropomyosin blockage is restored, and the active site, the contraction ends, and the muscles can now relax, so they aren't like tensed up anymore. This baby can go, I'm relaxed. And that's sliding filament theory. Yee.